covering Appendix A in the textbook, talking about synthetic division. Synthetic division is a method for dividing polynomials when the divisor has the form x minus c, c being just a number. So in our examples, they can both be divided with synthetic division because the divisor is x plus 2 and x minus 4, matching this format. Synthetic division is just a process, something you just have to learn to do. It's pretty simple. It just involves multiplying and adding. The setup is as follows. We're going to start out by taking this number right here and switching the sign. So it's going to be negative 2. And then we're going to make like a big division box, and I'm going to put the coefficients only in the division box. So 2, negative 3, negative 4, and 11. So those come from here, and it's the coefficients. And synthetic division goes as follows. The first number drops below the line. Anytime you go around the front, you're going to multiply. So 2 times negative 2 is negative 4. So I write my answer in my division problem. And then anytime I go down the column, I'm going to add. Negative 3 plus negative 4 is negative 7. And then I repeat the process. I go around the front and I multiply. And I put the answer in the next place over. Add. Multiply. Add. And now I'm ready to write my answer. To write the answer, I'm going to fill the variables back in, starting 1 power less than the original problem. So the original problem has x to the third. When I fill in my answer, I'm going to start with x to the second. 2x to the second minus 7x plus 10. And now I've run out of terms to fill in. So this last is the remainder. So I'm going to have plus negative 9 over x plus 2. And that's how you would write your remainder. Whatever this value is the numerator. The denominator is what you were dividing by initially. You could just make this a negative sign in the front instead of plus minus, but this way works also. Doing another example. So I start by taking this negative 4, opposite sign is positive 4. I'm dividing, utilizing the coefficients. Dropping the first number below the line. Going around the front and multiplying. Adding, multiplying, add, multiply, add, multiply, add. You'll notice this time I have a 0. That means there's going to be no remainder. I fill in 1 power less than the original problem. So it's 1x to the third minus x squared, no, not minus, plus 8x plus 15. And that's what we have. In this section, we also talk about the factor theorem. And that says that x minus c is a factor of a polynomial if and only if there is no remainder. So we're going to check whether the given binomial x minus 2 is a factor of the given polynomial. And we'll check that using synthetic division. So I have positive 2 in the front, my coefficients, run synthetic division, and I'm looking to see if I get a remainder. Since I have a negative 5 on the end, I know there's going to be a remainder. Since that's not 0, therefore x minus 2 is not a factor of our given polynomial. Now we check x plus 3, so I do opposite sign, the same polynomial, so I'm using the coefficients and running through synthetic division. Oops, just 5. Since this is 0, we can say x plus 3 is a factor.